registering. Okay, so now you're being registered. So, hello, Rutger. It's very nice to have you here today. How are you today?
Doing well, suffering from a serious cold, having traveled to San Francisco. It's a 9 hours time difference and sleeping not too well. But beyond that, I'm doing great. It's nice to meet you, and thank you for giving us the opportunity to talk about our passions.
Okay, so we can appreciate a lot that you took the effort after just coming back from San Francisco to take this interview. And I will just say that you are the CTO at Verum, a company based in the Netherlands. And today we are here to discuss a domain-specific language that you have been developed at Verum for supporting formal verification of code, in particular for embedded systems. So I hope I get the overview right, but of course we will dive into more details as we proceed in the interview. I think it makes sense to start with telling us a little bit about your company, Verum.
Yep, we were actually founded in 2004, so we've been around for a while. The original founders have left in the meantime, and I've taken over in the role of CTO officially since 2019, but effectively already since 2014. We've been serving with an original product which was called ASD in the beginning, and later on we rebooted the company and created design. We've been serving companies like ASML and Philips and Thermo Fisher, which all exist in the Eindhoven region in the Netherlands. So our focus has been quite close to home, and now we are starting to expand our horizon.
Yeah, well, quite a list of impressive clients, so it's not easy to find clients at that level. Okay, and today in particular we want to discuss about design, your domain-specific language. So why did you create it in the first place?
I grew up actually within Philips. That's where my career started, and Philips was adopting object orientation at that time, and I experienced firsthand that doing object orientation, which is inherently imperative, doing that in a concurrent environment is basically a recipe for disaster. It is just too complicated to get right, and especially on embedded systems where you interact with the physical world. Having some form of correctness is paramount. And I was introduced to the concept of model checking at my time at Philips by the original founder of Verum. And having seen that was a eureka moment for me. I have to do something with this. So that's the mission. Bringing formal methods, model checking to the masses, basically.
Nice. And can you tell us about the ideal user that you have in mind for design?
So preferably in the future, and that's not where we are today, anyone using a language like C or C++, or C#, Java, Python, doing a serious amount of development where either asynchronity or concurrency plays a role, whether it's in a cyber physical system or not, but with a high level of complexity, they should benefit from fully automated verification. So that's the group that we're aiming for. As far as I'm concerned, basically every programmer. but we're trying to lift the level of abstraction in order to capture requirements at the formal level, such that you can prove that throughout the entire state space of your software system, and even a system of systems. Well, this sounds very ambitious. We're not quite there yet, but that's the end goal.
Good. So, okay, so it's clear that you're targeting developers. So is the main advantage for them that basically they get formal verification for free by using the language, or is something else?
I want to say yes, but formal verification is not a free lunch. You still have to express what you want to prove formally. So if you're not willing to do that work, like doing test-driven development, you'll have to write the tests, and you'll have to do that intelligently. Otherwise, it will not help you. The same holds for describing the essential properties that you need to prove automatically. But that's the unique selling point. Yes. The scope of what we're trying to do is larger. Effectively, we're trying to augment our limited human mental capacity using the power of the computer. There are, of course, automation is one big thing. So we're doing code generation, we're doing simulation, we're doing verification. That automates a lot of the work that we as humans can do with our brain, but we're not that good at it to do it systematically and completely and correctly. So it's better to have the computer do that for us. So effectively, we're trying to figure out a new way of software engineering, which connects to the existing ways of software engineering, so raising the bar.
So you rightfully correct me when I say that formal verification comes for free, because it doesn't come for free, or if I understand correctly, require an extra effort. And so do your users or the people that you discuss with value formal verification enough to accept this extra effort? So do they see the value of this?
We've been able to quite naturally embed certain implicit requirements into our language. I have to briefly explain what the nature of the language is. So I talked about object orientation in a concurrent environment. Our language supports component-based development, which I look at as a subset of object orientation, a stricter subset. In object orientation, nothing limits you. You can make it as complicated as you want. In our approach, components are very strict. A component is a completely encapsulated behavior, being unaware of what the state or the implementation details behind its formal interfaces are. So design requires you to model any interaction with a formal interface. And an interface is just like an API. It lists the functions you could call out or receive, with data or not, with return values or not. But we also describe the protocol of that API explicitly. And then in our model checking, we prove that you've got an effective protocol contract, that implementations on either side of the interface maintain that contract. And that's a very natural way for most software engineers with some object-oriented background to describe their software. But on top of that, we have user-definable properties that can be expressed as Boolean predicates across many interfaces or across the local component state variables. So our language is inherently imperative, but also declarative somehow. I won't go into detail. If you want to know more, you should have a look at design.org. You can find all the information you want.
Good. Okay, and what were the main challenges in designing such a language? I suppose it's the first language you design, or so.
Well, when I joined Verm, there was a prototype of the concept of the original CTO, which was called ASD, or Analytical Software Design, I think it was called. And effectively, it was inspired by the clean room method by Harlan Mills, I believe, which was a tabular notation, effectively, of a state machine. And it already had the concept of something like components and interfaces, but because it was a table, it was not actually a language as such. So in design, we added the textual notation. And there have been many challenges from a business point of view, from a management point of view, a funding point of view, technology, and people point of view. So I don't know. I guess your listeners would be mostly interested in the technical side of things.
I think all the aspects are interesting because, if you write a great language from the technical point of view, but then you don't get support from people, then there is no point. So
exactly, yeah. And that's still our biggest challenge, stepping out into the world and finding recognition. That's why we're still actively developing the language. We don't believe ourselves that it's quite finished yet. And cooperating with our current customers is a great help there. If you've got more specific questions for our challenges, I'm more than happy to answer those. Otherwise, I'll just continue ranting.
Then I would be interested in editor support, because one aspect that sometimes people building a language underestimate is the difficulty of building an editor. So I wanted to ask, what effort have you done in this area? Or
we've had many experiments and enough failures, which is a successful experiment, of course, finding out that something doesn't work. And on the editor support, we definitely had a few. So our original product was a completely purpose-built Excel-like editor, which I personally found horrible, but some people really liked it. But that was the old product. When we started designing a textual language, it was the intent to be able to use any editor to write the language, but of course, modern programmers expect significant editor support. And initially, we selected Eclipse as the launching editor to be in, and we effectively developed using Extend, I think that's called, the language support. But in the end, it resulted in having, I believe, 4 or 5 separate parsers for the same language. So I really wanted to unify all of those parsers into a single implementation that could serve all the different uses of parsing. So finally, we settled on, we use Scheme to do most of our development. So the design is actually developed, written in Scheme. And in Scheme, we use Guile as our scheme implementation. It has a PEG, parser expression grammar library, which we extended, which is now being used in our LSP, Language Server Protocol plugin. We use it in our compiler for all the different use cases that our language offers. So we're able to make a single parser to rule them all. But that has been quite a challenge.
Yeah, no, it's an experience that I can relate to, because I also started my adventure in this area by using Xtext, that I think at the time was great. Then then probably Eclipse didn't evolve as well as we were hoping, maybe. But about evolutions, I think it would be interesting to hear about your plans for the language. If you plans more work on the technical side or on the promotion side, or any other direction in which you want to work?
So as CTO, my two primary goals or assignments are to push for more recognition in the outside world, build a community, but in doing that, of course, address or close the gap to what people actually need and expect from such a language. And for the foreseeable future, we've identified that we need to make data a first-class citizen in design. So we do support data, but if you take a single 32-bit integer, the state space of that integer is already vast. From my head, it's more than 4 billion numbers. And combining a few integers would blow up the state space during verification. So doing this effectively is what we need to achieve. So that's one of the extensions we're thinking of. And a long-standing feature that we want is system-wide functional verification. So I talked about those user-defined properties. We've come up with the language extension to express those properties, just Boolean predicates, but we need to lift that to the composition of our components to be able to do that performantly at the system level. So we believe that that is what the community is lacking for large-scale pickup of design.
Good. And maybe this is connected to the promotion side, but I also saw that you had a couple of publications on your work. So I wanted to ask you about your experience, about your experience in general with scientific publications.
I'd like to spend more time publishing about design, because I think that's an essential platform to get the message across. And it's also a way to have at least the academic community validate what we're doing, or invalidate, such that we can actually address those things. I think there's 3 papers out there now on design. I actually hope to start promotion work at some point and use that as a driving force to produce more of those papers. I think the last paper was written by Michele, I forget his last name, which I contributed to. So yeah, it would be great if the scientific community wants to research on the basis of what we're doing, because we are very much an R&D organization. is one of the ways to do that.
And I think you're lucky to be based in the Netherlands, because I think there are several research groups doing a lot of work at Delft or Amsterdam in this area. So nice place
Yeah.
for being based. And did you find any resistance from developers in adopting domain-specific language? Because sometimes a developer, consider himself a C++ developer, and this is really part of their identity. So everything else is, not their job.
Not acceptable. Yeah. That's an inherent fact, and we haven't figured out a true solution for that. Our approach to this is to have the design is actually intended as a coordinated language. So about 90% of the software has more or less been written, and we focus on the 10% which is missing as society. So we have to be able to deal with the 90% which is already written. People should not have to be forced to rewrite all of that code into a new language. So we're trying to make design more like a coordinated language. We've added model-based testing for existing implementations in the hope to bridge the gap for those, for instance, C++ lovers, not to have to say goodbye to the code they're still attached to. And of course, from a monetary point of view, leveraging existing code which works is essential. But fundamentally, if someone is really in love with a specific language and they don't see the benefit of what design offers, I can only say more power to you. And I expect at some point you'll find that it's a lot of work in conventional languages to be truly productive and to achieve a level of correctness, which I think society will push to raise the bar on in the foreseeable future.
I'm not sure if I understand exactly what you meant, but do you mean that I can have components written in other languages and write maybe the combination of this component in design, or did I misunderstood?
Yeah. So the design is intended to be a hybrid meta language, effectively. In principle, you can develop a new code in design because we generate C++ or C or Java or Python at request. So if you're doing greenfield development, all you need is design. But no one is doing greenfield development. It's usually brownfield development. So in order to add automated verification to a brownfield, that requires adding specification for what is already there and proving that that specification is consistent with those implementations. And we figured out a way to do that using model-based testing. And when we have those specifications, we can build the new code using design on top of that and know that it's consistent and correct using model checking. That's the hybrid approach. So the target code will always be C++ or C or whatever a user chooses, but they will do their orchestration and their verification at the model level, and with a push of the button, generate the missing bits.
Makes sense. And okay, so I think in this interview we explained the value of design, and so I hope that at this point people will be interested in learning more about the language. So can you give us any pointer for learning more?
Yeah, we have two websites. Free software, free as in free speech or freedom, not as in gratis. It is design.org. This is where we publish our open source or open core for design. They're actually a non-GNU project and hope to be a full-blown GNU project in the future. And we've got the commercial website, firm.com, where you can get your commercial support. On the design.org website, we publish the language reference manual. We've got tutorials. You can find the source code, and on the commercial site, you can find a binary version and get in contact with our sales.
Good, good. So we will make sure to add all the links in the transcript. And so my final question is, what do you plan to work on next?
I think priority one is community building, and secondary, extending the expressiveness of the language and the corresponding tooling. I think we've got about 5 feature branches still up in the air that need to become part of our release train. So I think in the last 12 months, we have fundamentally extended the language. We've added the concept of collateral blocking. We've added a defer keyword. We've added the concept of constraining interfaces and shared interface state. So these are all fundamental changes to the language, making it more expressive. And we'll continue to do that in the future. I talked about the system-wide functional verification. And I think that has the main attention on our side, which we will integrate, making data as a first-class citizen into. Yeah, I think
so
that's it for
now. Enough to keep you busy for a while.
Yeah.
Okay, so I think it's time for me to thank you again for giving this interview and for creating this domain-specific language. I think it can be an inspiration for authors to learn from your effort on the technical level, on the community building level, on your experience building, also editor support. So I think this has been very valuable, and thank you.
Thank you very much. I hope it will inspire someone out there.
Good. Great. So goodbye.
Bye-bye.